Next, we are going over isosceles and equilateral triangles, which should be familiar to you. The first one we're going over is isosceles. So remember that an isosceles triangle has at least two sides that are congruent. So if we look at our triangle ABC, those two sides here are AB and BC. The legs of our isosceles triangle are the two congruent sides. So our legs are AB and BC. And they are equal to each other, but I'm actually just going to put a comma to list the legs. A, B, and BC are the legs of our triangle. Then the base of our triangle is the side that is not congruent, the bottom of that isosceles triangle. So our base is AC. Our base angles are the two angles that are on the side of our base. So that would be this angle right here and this angle right here. Our base angles, we list those as angle A and angle C, or we can label them as BAC and angle BCA. Okay, and I just wanted to review that because remember when you're labeling angles, we need to start at the outside, come into the vertex, the corner of our angle, and then go out back to our third point. It's really important when we're naming angles using 3 points. That's how we do it. Our vertex of our angle is always in the middle. So here we have angle BCA, our C is in the middle because that's the angle we were talking about, and BAC, our A is in the middle, and that's the angle we're talking about. Okay, and then we also have our vertex angle, which is the angle where our two legs meet. So we have angle B. Okay, so those are some definitions when it comes to isosceles triangles. Now we're going to look at some theorems and things we have to remember when we're dealing with isosceles triangles. So our first theorem is that our base angles of an isosceles triangle are congruent. So remember, our base angles are those angles that are on our base of our triangle. So if this is our base, that means these are our legs, these are the congruent sides, then these two angles are always going to be congruent in an isosceles triangle. So we can write that as angle UFP, UFP right here. UFP is congruent to angle UPF. UPF here. Okay, my F is in the middle for my first angle, and my P is in the middle for the second angle, because those are the two angles we're talking about. So those are my base angles in an isosceles triangle, and they're always going to be congruent. Our next theorem says that the line of symmetry for an isosceles triangle bisects the vertex and is perpendicular bisector of the base. So if I draw in my line of symmetry right down the middle, I'm going to make a dotted line straight down the middle. That wasn't straight. Let me try that again. Straight down the middle. Okay. So if this is my line of symmetry, they're telling me that it's going to bisect the vertex angle. So that means that this angle right up here, and that blue line goes straight through it. That means that both of those sides of my angle are going to be the same. So this side right here is the same as this side right here. Then I know that the vertex is, then I know that it is perpendicular bisector of the base. So bisector, that word right there again, bisects, it means to cut in half. So that means that my base down here, this blue line down the middle, is cutting it in half. So this side right here, this side right here is the same as this side right here. And then it's also perpendicular, so that means that this angle right here between my line of symmetry and the base of my triangle is 90 degrees. Okay, so this is always going to be true for every isosceles triangle. Okay, my next theorem says that if two angles of a triangle are congruent, then the sides opposite to those angles are congruent. So that tells me that if I know that these two angles at the bottom of my triangle are congruent to these angles on my other triangle, then I know that the sides opposite those angles are also congruent. So the side opposite to this angle is here, and this angle is here. So then if those two angles are congruent, then I know that my sides of both my triangles are also congruent. So the way I want you to write that is if we have two triangles, if we say, if I know this, I know that these two angles are congruent, then I know this, where we have our angles are congruent and our sides are congruent. Okay? Let's look at some examples for our isosceles triangle. The first one says that EC is a line of symmetry for isosceles triangle MCJ. So if I draw in a line of symmetry and they tell me that point is going to be E, because my line EC is a line of symmetry, they tell me that the measure, that little m, means the measure of angle MCJ equals 72 degrees. So MCJ, which is this whole angle, is 72 degrees. Now this first thing they want you to find is the measure of angle 1. And that is not labeled on my diagram, but this is angle 1 right here. So it is just that little piece of the angle, angle 1. So if I know that this whole thing is 72, I need to remember that one of my theorems of isosceles triangles tells me my line of symmetry bisects this big angle right here. So if that line bisects that big angle, that means it cuts it in half. So to find angle 1, all I need to do is cut 72 in half. So if I take 72 and divide by 2, that gives me 36. So I know that my angle 1 is 36 degrees. Then it asks me to find the measure of angle CEM. So if I look here, CEM, well, that angle right there, I know that my line of symmetry is a perpendicular bisector to this line at the bottom of my triangle. If it's a perpendicular bisector, I know that that angle right there is 90 degrees. The other piece of given information that's not labeled on my triangle is that this line EM right here, that is 3. So I'm going to write that on. Hopefully it's labeled on yours, but that's 3, that is given. So then the next piece it wants me to find is the length of EJ. Well, if I know that this is an isosceles triangle and my line of symmetry is down the middle, it's bisecting, perpendicular bisector, so that means this side, ME, is going to be the same as this side, EJ. So if EM is 3, that makes this side 3 as well. And then the last piece it wants me to find is the measure of angle CMJ, which is right here, CMJ. So if this is my isosceles triangle, if I know that these two sides are the same, then I know that these two angles are the same. So if I know that my top angle is 72 degrees, there are 180 degrees inside of the triangle. If I already use 72 of them, take away 72 and I'm left with 108. So if I have 188 degrees left to split up into these two angles, and I know that those two angles are the same, I'm going to take that 108 and divide by 2, which that gives me 54 degrees. So if this angle is 54 degrees and this angle is 54 degrees, then all three of them will add up to 180. So that is the angles I'm missing here, 54 degrees. Okay, let's try number 2. Okay, if number 2 is an isosceles triangle, I know that I've got a line of symmetry straight down the middle, my perpendicular bisector. And my given information is not labeled yet, so I'll do that for you now. They tell me this angle is 55 degrees, and this side of my triangle is 8. Okay, so that is my given information I have about this triangle. They want me to find LK. LK is this side over here. If I know that this is my line of symmetry for my isosceles triangle, then that tells me that side is the same as this side. So LK is simply 8. Okay, then it wants me to find angle JKL. So if we start here, JKL. Well, if I know that these two sides are the same, then I know right away that these two angles are the same. And if that one is 55, then this one is also 55. So that is all you have to do for number 2. Okay, so next we're going to talk about equilateral triangles. So remember, in an equilateral triangle, all sides are equal. So I'm going to label that like this, all 3 sides. That tells me, looking at my triangle, those little dashes mean that all 3 sides are the same. Okay, and there's a couple theorems that go along with equilateral triangles. Our first one says that an equilateral triangle is also equiangular. And if you remember from last week, equiangular means all angles are the same. So if I know that all of my sides are the same, then I know that all of my angles are the same with all my sides. Okay, so that's what we need to know about equilateral triangles. And we've got 2 more theorems about equilateral triangles. So our first one says, each of the 3 lines of symmetry for an equilateral triangle bisects the angle it passes through and is a perpendicular bisector of the opposite side. So same thing with our equilateral triangles, like with isosceles. We have a line of symmetry going straight down, but now in this case that line of symmetry can go any direction. So we could have a line of symmetry there, we could have a line of symmetry here, or we could have a line of symmetry through this vertex. And in all of those cases, each time we drew that line of symmetry, every line was a perpendicular bisector and an angle bisector. So both of those halves of the angles were the same. and we're always perpendicular. Okay? So then we have that an equal angular triangle is also equilateral. So this is just the opposite of our theorem before. This says if we know that, that our triangle is equiangular, all sides are the same, then we know all of our sides are the same, along with our angles. Okay, so if we know all the angles are the same, then we know all the sides are the same. Okay, so now let's look at an example. We have RST is equilateral. Right away, I'm going to mark down all my sides are the same. See that word equilateral? I'm going to mark all my sides are the same. And I know if all my sides are the same, right away I can say all my angles are the same. I got all that information on my triangle just from one word. And it's really important to label that each time. So then I know that TX is a line of symmetry. So if TX is a line of symmetry, that is going to go through my point T, straight down the middle, and this point here is going to be my point X. And I'm going to label our pieces of our triangle, so we're going to call this angle 1, 2, 3, and that is all the angles we need. And then our other piece of given information is that this side is 8. So then it asks us to find the measure of angle 1. So right away I know that it's an equilateral triangle. That means all of my angles are the same. If I have to have 180 degrees inside my triangle, then that means that I'm going to take 180 and divide that by 3, which gives me 60. So I know every time I have an equilateral triangle, those 3 angles in my triangle are going to be 60 degrees. And if this whole angle up here is 60 degrees and it's divided into 2, 60 divided by 2 gives me 30. So I know I have 30 there and 30 there. So measure of angle 1 is 30 degrees. My angle 3 is this angle RXT. And again, if I know that that line through the middle is my perpendicular bisector, angle 3 is an easy one. That is just 90 degrees. Then angle S, I already wrote that in there because I know that all 3 angles were 60 degrees, so I can just write in 60. Then it asks me for the length of RS. So if I know that RT is 8, that means that RS must also be 8 since all my sides are the same. And if I have the measure of angle 2, again, I wrote that one in there already. We divide that in half, and that gave us 30 degrees. Then it asks me to find the length of SX, which is right here. If I know that my line of symmetry is a perpendicular bisector, it cuts that line RS in half. So if I have 8 divided by 2, that gives me 4 for SX.